Okay, welcome back dear students to the tutorial about spectroscopy. In the last video, we had discussed about the basic aspects of spectroscopy, different branches and the intensity, factors affecting intensity of spectral lines and the natural line width, the factors affecting the natural line width in spectroscopy. Okay, in this video we are going to discuss about more detail about the rotational spectroscopy. Okay, listen. Okay, listen. We already mentioned the rotation of molecule, the energy levels is in the microwave region. So in rotational spectroscopy, the radiation we are using is microwave radiation. So rotational spectroscopy is also known as microwave spectroscopy. Rotation of the three-dimensional molecule is a complex phenomenon. We can resolve this rotation into three components in three mutually perpendicular directions about the center of gravity. Okay, therefore we have three moments of inertia in three axes. They are denoted as IA, IB and IC. Okay, and based on the values of these three components of moments of inertia, that is values of IA, IB and IC, we can divide the molecule into three. The first one is linear molecule. As the name suggests, molecules are linear like HCl or carbon monoxide. Okay, in this case there are three rotation possible. You look here. One rotation is like this along the axis of the molecule. And this is the principal rotation, but this is very small, moment of inertia is very small, so we can neglect this rotation, and this is IA and this is equal to 0. Another rotation is like this, rotation in the plane of the paper. Okay, and the third rotation is rotation out of the plane of the paper. These are IB and IC, and these values are equal, that is moment of inertia due to rotation like this and moment of inertia due to rotation like this is equal to 0. So in linear molecule, IB is equal to IC, not equal to IA, and here IA approximately equal to 0. Actually it's not 0, its value is very small, but we are approximated it as 0. Okay. And next type is symmetric top molecules. In symmetric top molecules, IA and IB are equal, not equal to, sorry, this is not like this. Here IB and IC are equal, not equal to IA, and IA not equal to 0. Okay, for example, if we consider a molecule like CFCH3, CFCH3. Okay, here also there are three types of rotation. Here the center of gravity will lie more close to the fluorine atom in this bond, CF bond, because fluorine atomic number is 19, carbon is 12. So center of gravity lies more close to fluorine. So there are three types of rotation, one along this axis, and this is the principal axis, so it is denoted as IA. And other two are, this is the another one, we can denote it as IB, and third one, this is IC. Okay, that is we can see here. Okay, one rotation is along this axis, that is rotating of the CS3 like this. It is actually like the spinning of a top. That is why this type of molecules are denoted as symmetric tops. Okay, and this here, these three hydrogens are very small, and fluorine and carbon is a bigger atom. Therefore, this IA, this is IA, moment of inertia due to this rotation is IA. This value will be small, and other two are, this is the IB and rotation like this, rotation of the molecule like this, and next one is this one IC, molecule rotate like this. Okay, but these two are higher. That is, in this case IA is less than IB equal to IC, and these type of molecules are known as Proline symmetric top. Symmetric top molecules are two types. One is like this, IA less than IB equal to IC, and the next one is, another example is BCl3. Symmetric top molecule is BCl3. BCl3, we know structure is trigonal planar structure. Here also there are three types of rotation. One is this one, this is the principal axis, that is IA. Okay, second one is this one, and third one is this one. That is, neither of the axis passing through the chlorine atom. Here the center of gravity lies on the boron atom. Okay, that is, you can see here. Okay, listen here. This is BCl3 molecule, and this is the principal axis. Okay, there is no axis here, imaginary axis. So rotation like this. So rotating three bigger Cl atom, therefore its value is IA. This is the principal axis, IA, and therefore this is very high value. IA is very high. Whereas IB is axis is passing through this and rotation like this, and IC also rotating like this, and this value is lesser in this case. That is, here IA is greater than IB equal to IC, and this type of molecules are called oblate symmetric top. Oblate symmetric top. Okay, this is a second category, symmetric top molecules, and third category is spherical top. An example is CH4, a regular tetrahedron. Therefore, the center of gravity lies on the carbon atom. Here, all the components of moment of inertia are equal. That is, IA, IB, and IC are equal. Okay, and we can say in this molecule there is no dipole moment. We have already studied that only molecules possessing a permanent dipole moment are rotational active or microwave active. Therefore, this molecule have no interest for us because it cannot show rotational spectrum. And the last one is asymmetric top molecules. Here all the moment of inertia are different, IA and not equal to IB, not equal to IC. Okay, moment of inertia are different. Example is water molecule and vinyl chloride, CS2, double bond, CHCl, etc. There are many examples. Okay, and these are the four different types of molecule classified according to the values of IA, IB, and IC. Okay. Next we are going to discuss about rotational spectra of different